All right, welcome back. This is part 2 of section 4.3. And I left you with this question of listing all the possible permutations of 3 people out of 4 people called A, B, C, and D. And so right now, even though we are going to be discussing combinations, we're going to start with permutations. So how many permutations are there if you are to choose 3 out of 4? Okay, the order of course, would be relevant if it's permutations, and the repetition is not allowed. All right, so the point is you're picking 3, right? And so according to what we studied on page 1, you have 4 choices for the first one, and 3 choices for the second one, and 2 choices for the third one. And altogether, you should end up with 24 different arrangements of 3 names out of 4 if the order is important. Okay, again, without repetition. So the way you think about this is try to think about these in alphabetical orders. All right, so you can start with A. And in fact, if A is taken, then you can choose A for your second letter. So it'll be AB. And once you choose AB, you can have C or D for your last. And that's it, because you only have A, B, C, and D. So these are the only 2 choices if you have A, B as your first and second choices, respectively. Then you can have AC, right? But once you have AC, you can have B or D at the end. And then once you choose A and D, then you can have B and C at the end. And you can have, for the first 2, you have AB, AC, and AD, and so that's it, right? So these are the 6 different permutations starting with A. And you do a similar thing for B, C, and D. You have 6 permutations starting with B, 6 with C, 6 with D, and all together you have 24. Right. Here's the tricky question. Remember, in permutations, you have 24 permutations here. That's great. But in combinations, what's the difference? The order is not important, right? So if the order is not important, let me emphasize this, order is not important, then we have counted way too many different permutations, right? Because for instance, ABC, that's ABC. That's the same as ACB. And that's the same as BAC. Remember, I mean, those will still make the same committee of 3 people out of 4, right? BCA and CAB, CAB, and CBA. And if you look at all the other ones, they will have D. So we are looking for all the permutations without D. And lo and behold, you have 6 of them, right? So how many times did you list the team A, B, C? The answer is 6. Let me go ahead and list them, even though I have them circled. This is all the permutations without D. Okay, so it's A, B, C, ACB, BAC, BCA, CAB, and CBA. Okay, so these are all the permutations without D. Okay, that's what I mean. And now, yeah, I mean by this, why do I have 6? Can you explain why you have 6? Yeah, because you have 3 things. Okay, if you have to rearrange 3 things, in how many orders can you list 3 things, A, B, and C? And the answer is 3 times 2 times 1, or 3 factorial, which is equal to 6. So the point is, even though I have 20, listen carefully, even though I have 24 different permutations, if the order is not relevant, as in combinations, we have counted every combination 6 times here, right? You have 24, but they come in a group of 6, right? ABC comes in groups of 6. ACD comes in groups of 6, a group of 6. ABD comes in groups of 6, and so on. So what you have to do here is to divide this number of permutations by 6. And it turns out there are only 4 different combinations in this case, all right? Let me go ahead and write down those 4. Only 4 combinations. ABC, and remember the order doesn't count. So when I say ABC, I'm including all the ones circled, such as BCA and CAB and so on. So that's 1. And then you have ABD, okay? And then you have ACD and BCD, and that's it. Okay, those are the only 4 combinations, and therefore these are the only groups of 3 committee members that can be chosen out of the 4 candidates. Okay, now basically each combination is just missing 1. So in ABC, that's the list that does not have D, and ABD is the all the permutations that do not have a C in it. So of course the 4 combinations depend on which one of the 4 people you are excluding. That probably seems easier to understand. Okay, so out of the 4, yeah, let me go ahead and write another explanation down here. Hopefully this will make sense. Out of the 24 permutations, each combination was listed 6 times, and that's why you had to divide 24 by 6 to get your answer. And that 6 is 3 factorial. It's the order, it's the ways, number of ways to arrange those 3 letters. Okay, and that's 3 factorial. All right, let's try the next one then. And I'm going to use a little notation because that's what we use in the book, and it's really handy notation that we can use in mathematics. All right, so the number of ways in which you can choose 4 out of 7, we write it with C, capital C, and 7 here and 4 here. This number is called 7 choose 4, or the number of combinations of choosing number of combinations of 7 things chosen 4 at a time. How about how many ways can you choose 3 out of 7? This is the number of ways to choose 3 out of 7. That's C with 7 here and 3 here. We read this as 7 choose 3. The 7 choose 3 is the answer for the second one, and 7 choose 4 is the answer for the first question here. All right, let's do the first one first. To find the number of ways of picking 4 things out of 7, which is 7 choose 4. How do you do that? All right, remember, we count the number of permutations first. 7 times 6 times 5 times 4. Remember, we start with the set of all the items, the number of all the items first, and then we go down by 1 as you multiply these numbers. And once you have this many numbers multiplied, which is 4, numbers 7 times 6 times 5 times 4, then we stop. Now this top is the number of what? This is the number of permutations when you pick 4 books out of 7 or 4 songs out of 7 in a particular order. Okay, but as we saw here, this is way too many because 4 things chosen can be listed in how many ways? 4, 3, 2, 1, which is 4 factorial ways in which the 4 chosen can be rearranged. Okay, so you have to divide it by, you have to divide the number of permutations by this. Now, in this case, the numerator is going to be, what is that? 24, right? So 24 different ways are all representing the same groups, a group of 4 out of 7. Okay, so in other words, I can list this many permutations. That's a lot of permutations. That's the number of permutations of 4 out of 7. Okay, there are lots of them. I don't know what that is. It's 7 times 6 times 5 times 4, hundreds. Okay, but if you look at that list carefully, like you did here, okay, then for each of them, there are 24 representations of that same group. Okay, because ABCD is listed as ABDC and ACDB and so on, 24 different ways, and that's 4 times 3 times 2 times 1. So you have to divide the total number by 24. Okay, and when you do this, you get 35. So that turns out to be a much smaller number. Combinations are going to be much fewer than permutations. Okay, so there are 4 different ways. Sorry, there are 35 different ways to choose 4 out of 7. How about choosing 3 out of 7? Okay, so this time, let's count the number of permutations when you pick 3 books out of 7 books in a certain order. 7 to choose from for your first book, 6 for the second, 5 for the third, right? And that's it. This is the number of 210. Okay, is the number of permutations when you pick 3 out of 7. But again, remember ABC is the same as BCA and BAC and so on. This is too many because each of these permutations, or 6 of these permutations, represent one combination. All right, so you have to divide it by the number of ways in which you arrange those 3 that you have chosen, which is 3 factorial. So it's 3, 2, 1. And when you do this, you get 35. And so that is the answer to the second question. You notice something about this? I think you do, right? What you notice here is something obvious. Yeah, you got the same answer. Okay, is this just out of pure luck? And it is not. Okay, maybe you can figure out the pattern here. What am I trying to say? Am I saying that the ways to pick 4 out of 7 is the same as picking 3 out of 7? And indeed it is. Okay, and here's the answer. Okay, basically, picking is the same thing as not picking. Right? Choosing which 4 to include out of 7. That's the first question, right? You are choosing which 4 to pick out of 7. Maybe I can give you a more intuitive scenario. Let's say you have 7 children at home. You know, like you have a large family, you have 7 children. You only have 4 tickets to go to Magic Mountain. So 4 lucky kids out of 7 get to go to Magic Mountain. Right. So the question naturally is, in how many ways can you choose 4 out of 7? And if you can solve this problem, you can go to Magic Mountain and you can let your 7 kids do their work. But no, really, how are you going to pick the 4 kids out of 7 to take to the theme park? Right. That's a question of choosing which 4 to include in the team that would go to Magic Mountain out of 7, right? So choosing which 4 to include out of 7 is equivalent to choosing which 3 to exclude out of 7. Did you get that? See, the thing is, whenever you choose 4 children out of 7 to take to the theme park, you are basically making a choice of which 3 to leave at home, right? Or not to include in the group of children going to the park. So choosing which 4 to include out of 7 is the same as choosing which 3 to not pick out of 7. And that's why these numbers are equivalent. So for instance, 7 choose, let's see, if this were 7 choose 2, that would be the same as 7 choose 5, okay? Because the number of ways to choose 2 people out of 7 would be the same as the number of ways to choose 5 out of 7. As long as these 2 numbers add up to the total number, in this case 7, then your answer would be the same. And in general, the number of combinations would be much, much smaller than the number of permutations. Okay, so here is a little summary. If repetition is allowed, okay, and if the order is important, such as the telephone number, so you can use the same digit twice or 3 times, you know, and the order is important in the phone number. Or if you have one of those combination locks, how many ways can you choose the correct combination? Well, you can use the same digit or same letters again and again, right? And so the repetition is allowed. If the repetition is allowed and the order is important, use the use what? Use the multiplication rule. Okay, that's like the phone number, like license plates, or like the combination locks. Even though they're called combination, you don't use the combination formula, right? If repetition is not allowed, so you are talking about physical objects like books and songs and so on, and if the order is important, such as in playlists, then you use permutations principle, which is to count the number, total number, times the total number minus 1, times the number minus 2, and so on. And finally, the most complicated one is the combinations, right? That is the type of calculations, counting methods you use if the repetition is not allowed. You're talking about physical objects such as children and books and songs, and the order is not important. Okay, so you can tell that these two are closely related to each other. The only difference here, I mean, because in both cases, the repetition is not allowed. The only difference is that permutations, for permutations, the order matters. For the conversation, for the combinations, the order does not. All right, so I have 3 comparative examples here to conclude this section. Let's say there is, just imagine, okay, imagine that there is a ice cream store that feature 31 flavors. 31, it's just a random number. Okay, so 31 flavors are available at an ice cream store. How many triple cones are possible? How many triple cones are possible if you are, and I have 3 situations. Okay, if you can specify the order and you can repeat the same flavors, right? So you know you're looking for triple cones. Now, does it matter which flavor you order first? I mean, you may be really picky, right? Because you, like me, may love chocolate last because that's the best thing. And so you're going to choose that as the last thing you will taste. I will start with maybe vanilla and maybe coffee here and chocolate, right? That's a possibility. If you, and by the way, because I like chocolate, maybe I'll just get chocolate, 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 because repetition is allowed in the first situation, right? If you can repeat any flavors and if you can specify the order, this would be like filling 3 boxes with 31, 31, 31, because you have 31 different ways to order each of the 3 layers, right, independently. And in this case, it is 31 cubed, which is 29,791 different orders by multiplication order, you know, different flavor, different triple cones based on the multiplication rule. Look at the second situation with a little bit more restriction. You can still specify the order, but you cannot repeat any orders. So in other words, you have to pick 3 distinct flavors. In that case, you'll have 31 to choose from for your first flavor. And once you choose one of those 31, you have only 32 left because every choice has to be different. So it's 30 and then 29. So you'll end up with slightly fewer choices. That's 26,970 different permutations, okay? Because of this requirement that the repetition is not allowed. All right, so now let's just suppose that this is one of those places like Cold Stone or something where they mix up everything. Okay, so they mix up all that. And so it doesn't matter in which order you order these things because they will mix them up anyway to create their triple cone. If that's the case, if the order is not important, then how many different triple cones can you order if you are to order 3 distinct flavors? The answer, if the order were important, this would be the permutations problem. You know, you have 26,970 different order, different ways to order or specify the 3 distinct flavors, but they come in 6, the groups of 6. Okay, in other words, the order ABC is the same as the order CBA and order BCA and so on. I shouldn't use the word order here. The triple cone consisting of flavors ABC is the same as the one with the flavor BCA and CBA and so on, right? So even though there are this many permutations, 6 of them are exactly the same. And so they all come in groups of 6. So you have to divide this total number by 6. And that will reduce the number to 4,495 combinations. Okay, notice here, this is much, much smaller than that for this. And that's just a fact about combinations. Because the order is irrelevant, the number of possible combinations will be drastically lower than the number of permutations, right? Poor customer, they only have 4,495 choices. How can you live with such few choices? Okay, so that concludes our discussion on section 4.3. Next time we'll go to the last section of chapter 4, which is on probability, risks, and expected value. We'll talk about gambling for change. All right, until then, have a wonderful day, and I will talk to you later.